Hi, everyone. As a part of our attempt to allow folks to meet our various scientists here in the field, I wanted to give Marty Briggs the opportunity to introduce himself, his research project, and actually what he's doing here today. So, Marty, why don't you tell us what you're up to?
Okay, thank you, Ken. My name is Marty Briggs from the Hydrogeophysics branch of the USGS in Storrs, Connecticut. So we are out here, we're feeling joyful at Obi Joyful Creek this evening, and we're turning it green because we are interested in the distribution of groundwater discharges spatially along the stream, and then what type of discharge that is. So, all groundwater discharge is not created equal. Some are captured by beaver ponds where there's organic content that they interact with, and the chemistry can change significantly before that water enters the stream. Other discharges we've found come right out of fractures, so probably not changing too much from maybe the deeper groundwater flow path.
So, to interrupt here, we're looking at kind of the terminus of the Peeler Basin. There's a mapped fault system here, the Peeler Fault. And Marty, you were describing to me kind of down in this general region, you've got very obvious emergence from that fault zone right into Obi Joyful Creek.
That's correct. Last summer we mapped this with the UAS with drones, and we picked out several emergent, strong flowing springs from the fault zone, running about 6-7 degrees C when the stream was about 14 degrees C, so they were very obvious. It's running not quite as hard this year. Obviously, water levels are down a bit, but we've been sampling those for chemistry and seeing what's showing up in the river.
Fantastic. And so, if memory serves, your team's comprised of quite a diversity of disciplines. Is that right?
That's correct. We've got folks kind of trying to push the boundary on geophysical methodology, so using various sensors to locate iron oxides that are associated with anoxic discharges. So those students are from Rutgers University. We've got our drone team that's a mixture of UAS or USGS folks from around the country. We've got some interns with us. Dylan's a high school student.
As a part of which program was it again?
The Volunteer for Science program.
Yeah, you're volunteering for science instead of making tacos at Taco Bell. Well done. Introduce yourself.
I'm Kimberly Moore. I'm a USGS NAGT intern and also a graduate student at the University of Missouri.
Fantastic. So to get a little glimpse here as we wrap the video up of kind of what you've done here, describe what's involved in a tracer release experiment like this.
Well, first of all, we don't want to turn the stream too green because this comes down by the campground and down toward town. But basically, we want to. We've got these fluorometers calibrated for a certain range, so we want to get an injection that puts mass into the stream within our calibrated range, and we're going to see that dilute with distance. So right now we're at 90 ppb. We expect that to be 30 ppb at the bottom, and we can walk down the stream once it's at a plateau level of concentration along the stream and look at sequential dilution with space. So basically, we can have a very high spatial resolution template of groundwater inflow, assuming we're not losing mass.
I see. So really, this is going to get at a quantitative measure of the total groundwater contribution along this particular reach of stream.
Yeah, and whether that's related with these faults, related with the Redwell tributary inflow, and maybe some inflows that we haven't found yet.
Fantastic. Well, thanks so much, Marty. Appreciate it.
Thanks.